because we are going to see classification, not normal classification, text classification. Okay, so this is an Amazon customer review data set. Okay, I have taken it from the kaggle.com, so I have mentioned the website as well. So Amazon Alexa like product is there, right? So review of the customer. Okay, some 3000 Amazon customer review has been taken. Based on that, we are going to find, whether the customer has given positive review or not, and how using the TensorFlow method, it can able to predict whether it is positive review it is giving or negative review it is giving. So for this, still now we are dealing with numerical type data only, like numbers will be there, or else we will convert basic columns like mail or anything to number format by giving dummies, right? So here one more thing also we will do, that is called tokenization or else count vectorizer. Okay, what this count vectorizer is going to do? So here what will happen is the text is there, right? The customer review is there. So each customer's review will be taken. Okay, and then from that particular sentence, unique values will be converted into some table format. Okay, here if you see means like table format it has created, and this is the first document like that given, right? So what it will do, how many times this that particular this has appeared. So one time means it will add 1 to it. Okay, and then is there. So for that it will add 111. Okay, and then it will go for the second sentence. So here again this is the document. Here two times document is given, right? So it will add 2 to the that particular value, and for remaining it will give it as 0. Okay, if exists means it will give it as 1 multiple times means it will add the count. For others it will going to be 0. Likewise it will convert the values into 0, 1, 2, or like how many times it is occurring. So it will create one table with unique values, and each for each statement it is going to create some values to it. Okay, if it is present means it is going to be 1, multiple times present means how many times it is present. If not present means it is going to be 0. So this is going to be the format. Like if you see means it is evenly dividing, right? So here only 3. If it is divided means 5 columns only it should have come. So here some new word is there, like second is there. So for second it will create another one column. Likewise it will create for all the sentence. Okay, so and then finally we will find the confusion matrix, and then we will decide, okay, whether the predicted value, we know true class is there and then predicted class will be there. So if it is a positive review and our predicted value is saying as positive means that will come in the first box, correct? And if the predicted value is false and then the actual value also false means the count will be added to my this particular column, right? Right and down. So here this is partially wrong, like which can be ignored as well. Why? Because what has happened? The person, the predicted value should be it is plus, but it is not having. Okay, it is a negative command like that we can take. Whereas this should be taken into consideration. Why? Because um, it is predicted as like negative, but it is a positive thing. Okay. Uh, so if you are taking it with an exam, okay, that's why we call it as type 1 error and type 2 error. Okay, type 1 error can be ignored to some extent. Okay, because for example, you have taken here is so cancer patient is there, 9 cancer patient is there, and 91 healthy patient is there. So totally 100 data points we are having. Actually, this itself is considered as an impure data. Why? Means we don't have any balanced data here, right? Only cancer patient is having 9 and healthy patients are 91. So automatically what our model will think is it will try to fit the cancer patient also into the healthy patient category. Okay, so here if you see means for example purpose only, so it is taken as total positive is 1. Okay, and then total negative is 90. Okay, but what is the value? 91 were healthy people, right? So F1 is equal to 1. So 1 it has predicted wrong, correct? And 8% it is saying they are having they are not having cancer, but they are actually having cancer. So that is a risk, right? Here the person is not having cancer, but it is saying as cancer. So this can be easily rectified. Again, if you are taking any test means, the doctor can identify that person is not having cancer or anything. But whereas in this particular case, if the person is having cancer and we are predicted as not cancer, means that person will not go for further medication, so the risk will be increased, right? So all this has to be taken into consideration. So we know how we will calculate the accuracy score. By adding this to particular value, we will subtract, sorry, we will divide it with total values. Okay, so here we will take number of rows we have taken and then how many has been predicted correctly. So here in this example, so 91% it has predicted correctly, like that we can say. Okay, so for this we will see one program. Okay, so any doubts in that like previous example or anything? It is going to be like small change only in like how we want
Uh,
to. Yes,
sir,
yes,
sir,
yes,
what will happen if we change the last layer in that? Uh, we have two hidden layers and one last layer, right?
yes.
Yeah, in this, so if we, what will happen if we change the last layer units? Like we have only one neuron, right?
Like here you want to change it.
No,
Here
no, no,
one now.
below, yeah,
We want
yeah,
only
two,
one output only, right? We want the price
okay,
of house. That will be one price only, right?
mm,
This is output. Okay. In case if you are going for classification type means you will specify how many classes are there. Okay. So here
okay,
in
okay,
the new example I will show. Okay. How it is completely how many classes. How many outputs you want. Okay. Anyways, in classification also you will get only one output, major output, right?
okay, sir.
So remaining will be like percentage wise it will vary. Okay. So here also I have mentioned like we are going to take the Amazon customer review. So this will be available in this kaggle.com, this particular website. So you can click here and go to that particular website as well. Okay. So to save our time, I will just copy it from here. Okay. Okay. So data set here I am going to take is going to be Amazon Alexa TSV file. Okay. So data frame of Alexa pd dot. Okay. So here I will specify how to split my data. So based on tab. Okay, because uh, it is separated by tab space. Okay. So okay. So here if you see means they have given the rating, date, and then variation, which is different models, I guess, like walnut finish or charcoal fabric, like that. Lot of things will be there, variation. So for that, what type of review we have got? Okay, Lawmaker or something. So here feedback 1 and 0 we will have. 1 means it is a positive review, and 0 means it is going to be my negative review. Okay, here we don't need any data or ranking, right? So in the data cleaning part, you can remove them as well. Okay, here I'm going to use the data set completely. So I just remove it for you. Okay, ranking and date we don't need, right? So, okay, here what we are trying to find. So final is the feedback. Okay, whether they are given the positive feedback or negative feedback. Okay, based on the text, we are going to do the tokenization method, right? So we will extract all the values and then we will find the tokenization, and then based on that we will find okay it is a positive or negative review. Okay, so simply I will remove. Okay, data cleaning. uh, so drop what are all the columns I don't need. So date and rating. sorry, rating. Okay, and then I have to specify the axis. Okay, axis equal to 1 means column. And then what I have to do, I have to update it in my actual data set. Okay, okay. Now I have to create dummy variables. Okay, for the variation. Why? Because then only we can able to differentiate the how many different variations are available in our data set. Okay, so this also we have done, right? So base 0 1 2 like that it will assign. So if you are giving get dummy methods means it will convert into 0 and 1. Okay, if 0 means it is not present, how many, for example here we are having two variants like that, assume. So charcoal fabric is there and walnut finish is there. So if it is 0 means charcoal fabric is 0 means then it will be walnut finish. If it is more than 3 means based on the zeros and ones we can able to find, okay, which variant it is coming under. Correct. So for that I will create variation dummy. Okay, separately it will going to return me some value, right? So based on that I will give. So get dummies. Okay, for what we are going to get the dummies, sorry, data frame Alexa, and then drop first. Why we give drop first? To avoid like removing one column, okay, which we no need. So now if I go and check my variation dummies means, okay, see, this many variants are available. Okay, black dot, black plus, black show spot, like that. This many is there. Now it has been converted into zeros and ones. So totally how many rows I'm having? Like 3150 rows is there, and 15 columns I'm having. So 15 variations are there. Okay, as per now. So now what we have to do? We don't need the variation in my actual data set, right? Instead of this, I'm going to pass this as my new, I'm going to concatenate this new 15 columns into my actual data set. Okay, for that what we have to do? So first I will drop df Alexa. Okay, so then simply I can give it as in place equal to true, so which will update in my actual data set itself. Okay, otherwise you can specify it as df underscore and all. Okay, so now if I go and check my df Alexa means what will be there, so what will not be there, so our variation has been removed from our actual data set. Now we have to concatenate this two, okay, this 15 columns with my data set. So for that what I have to do, so just df Alexa, so pd dot concat. So again df Alexa comma variation dummies. Okay, okay. So now it has been added successfully into my actual data set. Okay, this should come here. Then what we have to do? Hmm. Here is the extra thing we are doing for the text data, right? So tokenization. So all the reviews are going to be converted into the tokenization format. So for that, in the scikit-learn itself, for separately for text, we have some extension. As mentioned, like count vector is present in our scikit-learn itself. Okay, so scikit-learn dot feature extraction. Okay, see here we are having feature extraction dot text. Okay, we are dealing with text. So and from that we are going to import the count vector. Okay, so and then what we have to pass? Okay, we have to initialize it, right? So I'm just giving it as vectorizer, sorry, vectorizer equal to, okay. So now it has been initialized. So we have to change the review, right? What is the name of our column here? Verified reviews. Okay, so here's this. So Alexa, like count review or anything you can give. Vectorizer equal to vectorizer dot fit transform, like how we will do for scaling, standardization and normalization. Similar like for text, we are doing this. Okay, so df underscore Alexa, so verified reviews. Okay, now we will run and check. Okay, so now if I go and check my Alexa counter means, okay, it is in some function format, so I can check the shape of it. Okay, okay, now I check means I'm having 4044 columns. Okay, so different words may be present in our data set. So I'm getting 4400 columns, and then 3150 rows are there. Okay, so for this we are going to do some scaling. Mm, okay, so here problem is we cannot directly use this, or we cannot able to add it into our data frame because it is in different format, right? So we have to convert it into array format. So then only it will be easy for us. First we have to correct like convert into data frame format. Sorry, why we have to convert into data frame? So then only we can able to concatenate, like how we have did it for this column we have done, right? Variation. So similar like we are going to do for here also. So for that I will comment it like, so converting to data frame to concatenate with original data frame. So for that what we are going to do is, so I will create one reviews pd dot data. So Alexa counter, directly I cannot do this, so I am going to give it as to array. Okay, so this will convert them into array, because directly when we are checking Alexa counterizer means it is showed in some function format, right? So that has to be converted into array format. Okay, then it has been converted into data frame format. Then we will concatenate this review to our actual data set. Okay. Mm, what else we need to do? I will run this first. So before that, now we don't need this verified reviews column, right? So we have created the tokenization, right? So from the actual data set, I will remove the particular column. So df Alexa dot drop. Okay. After converting only we should have to drop, otherwise we cannot able to access the data, right? Okay. Reviews, verified reviews. Okay. So uh, access equal to 1, in place equal to 2. Okay, so We have removed that also. So then we have to concatenate. So for that, um, same previous line only. This only we are going to use. Instead of variable dummies, we are going to give it as reviews. Okay. So let us run this and check. Okay. So up to this, we don't have any problem. Okay. So now training and splitting. So in our table, we have created all columns in some numerical values, right? So and the final output we want is feedback. So except feedback, we will take it all other columns as our. Otherwise, I will just print this to see in what shape our data is right now. Okay. See now, like for sample, I have taken 5 rows, and right now we are having 40, like 4060 columns are there. Okay, in that we are going to take feedback column came in the first. See, so it will be easy for us to access as well. Okay, so for Y I will take the feedback, and for the X I will take the remaining data set. Okay, so
Sir,
uh, yes, ma'am. I think your voice
sir,
is low, a little bit out. Yes, ma'am.
sir, that 4034, 35, that and all the feedback that is given by the users, right, sir? That the tokenized thing, right?
This 4060, ma'am.
Yes, sir. That column
Yes, yes,
4034.
yes, ma'am. Based on the users, after doing the tokenization, it has converted into that many columns by
Okay,
unique.
that and all words that you have seen like yes with or.
Yes, yes, ma'am. Yes, ma'am. All
Okay,
words
sir.
are now converted into number format.
Okay, sir.
Okay, similar like we have seen in the PPT. Okay, so it will be easy for us to access if we are giving it as. So for X, I'm going to take. So this method also we can do. Like we are having lot of columns, right? So to avoid confusion, simply by giving drop. Okay, this is also one way of extracting the data, right? So this is not going to affect my actual data set. This is going to give me one new data. So now in my X, I will not have feedback. Apart from that feedback, I will have all the remaining columns. Okay. See, one column has been removed. So remaining 4059 columns I have taken, and totally we are having 3150 rows. Okay, as per our review, sorry, Amazon review. And then for Y, uh, I will take df Alexa feedback alone. I will take. Okay, okay. So now, sorry, train splits here I have done now. Okay, so we have to do the splitting and training part, right? So that we know. Model selection, import. Here I'm taking 20 percentage. So randomly I'm giving some 5 or any value we can give that we know. Okay. So here comes the change in our model. So previous example we have seen for regression type. Okay. So here we are going to do see for like classification method. Okay, more or less going to be same only. Okay. Uh, Here for differentiation purpose, I will give it as, instead of giving it as model, I will give it as a classifier. Okay, just for a change. So same like tf dot keras dot model. Okay, so in our classifier we are adding, so sorry, so here again I'm giving some less units. For example, I'm giving like 100. Okay, beginning itself I'm giving some 100, and then activation, so same ReLU method I'm giving. Okay, input, how many inputs we are going to pass here? So 4059 we have seen here, 4060, and then 4059 columns we are going to pass. Okay, so here we have to specify it as 4059. Okay, in this type of problems only we will take some more time to, for doing each epochs. Even if you are giving 10 or 5 epochs also, it has to check for each values, right? So in that time it will be a little bit slow. In case if you are using Google Colab, in that case if you are turning on GPU means little bit faster you can able to do the iteration process. Okay, okay. Keras dot layers. Here I will create only one dense layer. Okay, instead of going for multiple dense hidden layer, sorry, not dense layer, hidden layer. Okay, again I'm giving an activation function as ReLU only. Okay, so and my final is going to be my output layer. Okay, so here I have to give only one, so one output I am going to get. Okay, whether it is a true or false, like that. So activation, here I can give like sigmoid method. Why? Because no need to go, no, negative value means it will be stop with 0, positive value means it will stop with 1, so that in between we can give some value and check whichever value we are getting more than like 0.5 means we can say it as positive review, and the values which are getting less than 0.5 we can say it as negative review. Like that we can adjust our value. So for that purpose I'm going for sigmoid method. Okay, sorry, what error I have done? Unexpected end of file passing. Okay, I haven't closed it properly. Sorry. Okay, still position argument follows keyword argument. Okay, I sorry I forgot to give equal to. Okay, that's all. Okay. So if you want means you can check for summary also. Like for any model if you are creating, just if you give summary means it will show you some details like how many layers it has created, output how it is going to come, how many parameters it has taken. Likewise, we will get some summary just for knowing purpose. Okay, dense to like that only it is taking. Okay, okay. Then we have to compile it. So that is important. So classify dot compile. So again, I'm going to use the optimizer as my Atom. So Atom is mostly used. Okay, you can also use it. And here loss, we will not go for the mean square error. Why? Because this is classification type problem, right? So here there is one another method called binary cross entropy. Okay, that only we are going to use for finding the loss. Okay. So if it is a regression type means we can go for a mean square error or mean absolute error or anything. So here I am going for, sorry, did I give spelling correctly? TRO, sorry, entropy. Okay, here I'm going for binary cross entropy and matrix, whichever you are specifying only. Okay, I want accuracy. Okay, so let me run this. So, and my final step is creating epoch history. Okay, so classifier dot fit, and then epochs I am giving it as 10. Okay, so let us see. Okay, it is showing some accuracy as 99 or something. Okay, it is. See, initially it started with 91, and it is slowly increasing to 99.33. Okay, 99.33 is coming often, 39, 36. So small difference only is there. Okay, let us check it in the graph as well as the accuracy score, and then we will see whether we can increase it or or else it will be our final output or not. Okay, so for that I'm just going to plot it. So to make it easier, so I will take it from this code. Okay, um, okay, here I have loss. Here I don't have any validation loss. Okay, just I'm going to find the model loss. X is going to be my epoch number and Y is going to be my training loss. Okay, so and then similar way we can find for accuracy as well. Okay, let us see whether I have given it correctly or not. Okay, see, this is my loss rate, and this is going to be my accuracy rate. So when it was 0 epochs 2 4 6 8, sorry, we can able to see our line is like small changes from here itself. We can able to see the difference as well, right? So 91 is there, and then 95, 98, then the 99, 2 3, like 2 3 3 3, then 3 6 we got, then 3 9 we got some loss in here. Likewise, some changes we can able to see, like before going to graph itself we can able to see something. In case 100 or if more than 50 like that you are giving, means it will be harder to search everything, right? In that case our visualization will be little bit helpful. Okay, where loss is very high or where we are getting some more accuracy or not. Okay, so we will check the score as well. So what are the scores we will use for evaluation, validating? We'll go for confusion matrix and accuracy score, right? So from that we can finalize, okay, for this values I'm getting this particular output, I mean this much accuracy. Okay, so confusion matrix, accuracy score, and then so for confusion matrix, so directly I will give it as. So what I will pass, just y train and y predicted value, correct? Okay, again I missed that particular thing. Training only I have did, right? Okay, so here what we can do is, I have done only training part, right? I haven't tested with anything. So for that we can predict test, what we can do. We have splitted already for y test, sorry, x test. So that we will pass it into our model before doing this step. So for that, what we have to do? So y predicted value. So we have called as classifier dot predict. So what I'm going to predict? X test value. Correct. Okay, I have predicted it. So now I will check it with my confusion matrix. Then it will be correct. So y test is there and then y predict is there. Correct. So similarly, I will try to find the accuracy also. Accuracy score. Same y test. Okay, what error is coming? Class meta handle a mix of binary and continuous tragedy. Where I am in the print y test and y predict. Okay, so here what happened here is, so y predict in some different format, right? Whereas our y test in, so 1 0 normal format. So what we are going to do is we are going to convert this into similar like 0 and 1 format. Then only we can able to perform this particular operation. So for that, as I have mentioned previously, I am going to change like here values will be in between 0 and 1 only. Okay, so whichever value is less than 0.5, I will consider it as a negative value, and whichever value is greater than 0.5, I will consider it as positive review. Okay, so for that, I can update here in this itself. Correct. So why I'm changing, you understood, I guess. Okay, just y predict greater than 0.5. Now if I check my y predict means, see now it has converted into true false. So it is easily can be compared, right? True means 1, false means 0, we know. And the output is also 1 0 format. So now I will run it and check whether it is. See, now I didn't get any error and I have solved it. Here if you check means 18 is there and one like some loss is very less only. Okay, in this case. Okay, so similarly, what from here itself we have found that the 0.9 means some extra score 90% is there. So we can also try to increase little bit. Any possibilities there means we can try to increase it. Like giving, instead of giving it as 100, if I'm giving 200 means any changes coming or not. Okay, like point values only it is going to change in my assumption, or else I will change it and see. Okay, instead of giving it as 100, I'm giving it as 200, and let me keep it as 10 itself. Okay, let's see any changes coming in my accuracy or not. Okay, okay. Um, no any big change I can able to see, right? Similar output only I'm getting. So let it be 100 or 100 is enough. So like this only we can able to identify, okay, whether increasing is going to any make any change or not. So here any new change as it has bring, so I will make it as 100 itself. Okay, so this is what for classification type. So we have seen different classification, how we can do it for text based. So hope you might have understood this. So only, I mean, new thing we have learned is how to do tokenization. So and then we know about dummy gradient and other things you all know it, right? So any doubts in this? So not all the time we may need epoch counts to be 50 or 100 or anything. Okay, always, like if you are taking any new data set and trying, means always start with smaller values. Okay, then based on the error or loss value, you can increase the epoch count. Like as I told, maintain with two hidden layers, two or three is maximum you can use, and by increasing the units, try whether you can able to achieve it more accuracy or not. Okay, so that's all for today's class.